Okay, so hi, we're team number 3 and we're presenting the Gay-Lussac law presented by Leonardo Calvo Castro, Miranda Vargas Estrada, David Peña Magaña, Pamela Fernández y Gabriela. Y por mí, Isabela Pérez García.
The pressure of the mass in a certain gas can directly vary with the absolute temperature of the gas when the volume finds itself constant. As well, attached to this, we have that Charles' law is similar, but at the same time different from Gay-Lussac's statement. You see, Charles changes the volume with the temperature. Pressure, in this case, stays equal. But Gay-Lussac changes the pressure with the temperature, in which the volume stays equal. So they are actually pretty similar. We can see the difference in this, but it's a good example so we can understand in a better way Gay-Lussac's law.
Okay, so the mathematical expressions are P1 over T1 is equal to P2 divided by T2. So this is when the volume is constant. The next one is when the pressure is directly. That it means that pressure is also replaced on the temperature. And the most famous, that is the pressure divided by the temperature equals to the K constants. This formula is the most famous of this law.
In the law of Gay-Lussac, the gas is inside of a container, so it can change its size. That means the volume stays the same all the time, because the pressure depends on the change of temperature. For example, if the temperature increases, the particles move faster and hit more the walls, so the pressure increases. But if the temperature goes down, the temperatures move more slowly, so the pressure goes down, decrease. Why this happens? Because the hotter particles have more energy.
Gay-Lussac's law says that when volume stays the same, pressure and temperature are connected. If temperature goes up, pressure goes up, and vice versa. If temperature goes down, pressure goes down. The formula is P1 over T1 equals P2 over T2. Now let's see a quick problem. If a gas has a pressure of 2 atmospheres at 300 Kelvin and the temperature increases to 450 Kelvin, the new pressure becomes 3 atmospheres. That's one problem. And another example of a problem would be if a gas has a pressure of 120 kilopascals at 250 Kelvin and the pressure increases to 180 kilopascals, the new temperature becomes 375 Kelvin. So you need to remember that if more heat is supplied means more pressure, as long as the volume doesn't change and stays the same.
4 measure units that we use in Gay-Lussac law. In first place, we have the ATM or atmosphere, that means pressure. In second place, we have Kelvin or K, that means the absolute temperature. In third place, we have the liters or L, that means volume. And finally, we have the mole or moles, that means that means the amount of substance. So we have a rule that we have to follow, and is that to solve these problems, you have to ensure that the units are consistent. If they are not consistent, you have to convert. Thank you.
These laws are applied in our everyday lives, even though we sometimes don't notice it or we don't know about it. So these are a few examples of things that happen to us and we don't know that has the law applied in them. For example, the aerosol cans. You've probably seen that like do not apply fire on it. Warning on a can of hairspray or spray paint. And that's the Gay-Lussac's law, acting as a safety warning, because the metal has fixed volume, it can expand. So when when you heat it up, the gas molecules start moving like crazy and start slamming into the walls of the can. And well, that can be really dangerous if it happens to you. And finally, here we have our references. Here we have a note that please, Dr. Ever, if you can read it. And also, thank you for your attention. Have a joyful day. Thank you. Bye.